All right, so we are looking at homework questions. This is number 5, area between two regions, y equals 20 minus x squared and y equals negative 5x plus 6 on the interval from negative 3 to 2. So g of x is negative 5x plus 6. That's what I want. And then we're told to only look between x equals negative 3. So graph x equals negative 3 and x equals 2. And find a window that I can see that. And one thing I like about GeoGebra, it's got a move graphics tool, so I can easily just scale the axis right on the screen. Oh, this is interesting. So we want the area between these curves from here to here. So we're going to get here, the line is on top, and over here, the parabola is on top. So we just need to break that down. Yeah, so let me get a copy of this. So we want, so the area between the graphs, so it's not saying which is on top, which is on the bottom, it's just saying between. So over here, this is between them, and I got to stay between x equals negative 3 and x equals 2. So those are those vertical lines. And then over here, I get some more area between them. So I want to find those two areas. And we got to break them into two parts because they switch who's on top. So this first area right here, let's call that number 1. That's going to be the integral from negative 3 up to that intersection point. And it looks like the intersection point happens at negative 2, but I need to confirm that. So if I set these guys equal, 20 minus x squared equals negative 5x plus 6. I'll add the x squared over. And then subtract the 20, which gives me what, 14 minus 14 equals 0. And that factors as x minus 7 times x plus 2, which means x equals negative 2 is definitely that intersection point right there. Okay. And GeoGebra or Desmos will tell you that pretty easy too. So we're going to go from negative 3 to negative 2, and the line gets to be on top, right? So that means we're going to start off by saying the line first, and then subtract the parabola because it's underneath. So 20 minus x squared. And be careful with your parentheses. So we can clean that up for area number 1. So let's see, cleaning that up, integral from negative 3 to negative 2. We're going to distribute the minus, so we'll get a positive x squared. Still have the negative 5x hanging out, and then we'll have 6 minus 20, which is negative 14. Matches our expression down below. So we just need to find an antiderivative for that. What's an antiderivative?
1/2 x squared.
Almost? Nope.
Or 1/3 x cubed.
Cubed, yeah. So I'm going to write it as x cubed 3 minus this one's going to be 5x squared over 2 minus 14x. And that has to go from negative 2 to negative 3. So use technology to your advantage. I would enter this as a function in GeoGebra, Desmos, wherever you like, to make it easier, quicker. So my antiderivative function, I'm going to call it a of x equal to x cubed, ooh, what the heck? X cubed, there we go. 3 minus 5x squared over 2 minus 14x, is that right? Get that right? And then I just want to evaluate that at the upper bound, so a of -2, and subtract the lower bound, a 3. So I get 29.6, which is what, 4 5/6. Yeah. So again, technically, I've got -2 cubed over 3 minus 5, -3 squared, use parentheses. It's 14 times -2, all minus parentheses.
Wait, why is that a -3 in the second parenthesis?
Ooh,
Yeah, it's
2.
It's like,
Sorry, I must have looked over there. And then the next one gets the -3. So -3 cubed over 3 is 5 times -3 squared over 2 minus 14 times -3. And the arithmetic on that comes out to the 29.6. So that's for area 1. So then you got to repeat that, but change the order of subtraction for area 2. What am I going to integrate from and to on area 2? Yeah, so from -2, no, -2 to 2, because we're told to stop there. No, so we're going to go from -2 to 2 there. So new page. So for area 2, we've got the integral from -2 to 2. Now I got to switch the order. Yeah.
So does nothing happen even though it drops below the x-axis?
Yeah, so that doesn't matter, and I'll show again why. So this is that opposite order of subtraction. And Ruby's question was, does it matter that part of it went below the x-axis? And it turns out it doesn't, and here's why. This, what I'm drawing right here, is the height of a rectangle or a sliver. And to find the height, you always take the upper value, the top value minus the lower value. And so if we look back at our picture here, what gives me the top value in this region? Parabola, right? Is the top value. What gives me the lower value in this? And it doesn't matter whether the line gives me positive y values or negative y values. The distance from here to here is always the upper minus the lower value. And it doesn't matter if they dip below the x-axis or they're all above or all below. As long as you have this order correct, you're good. The thing that was important here is we had to do 2 different intervals because they flip who's on top. That was the important part. So then we repeat that process for this right here. Now, what happens when you change the order of subtraction?
sign switch.
The sign switch, yeah. So that subtraction is basically just going to give us the opposite of what we have right there. So I'll have a -x squared plus 5x plus 14 when I clean that up.
Let's do it.
What's that?
You just apply different limits to it.
And there's different limits on there too, yeah. So what I'm going to get here, pen is not, come on. There you go. There we go. So now I have the integral from -2 to 2. Here the x squared is negative. Minus a negative gives me plus 5x. And then I have 20 minus 6, which is plus 14. So it's just the opposite of the one we were already working with. And then we have to take the antiderivative and evaluate at the bounds. So antiderivative, like before, just different signs. -x cubed over 3 plus 5x squared over 2 plus 14x from -2 to 2. So plug those in and then try my calculator. Hang on. push this a little bit. It's now, what's next? -2. So just be careful when you write this down and type it in. And let's see what this comes out to be. So do I have the same antiderivative as before? What's the difference? It's the opposite. Yeah, it's the opposite. So if you wanted to use that function, you just need to be careful to use the opposite. Otherwise, make a new function that's the opposite of that one. So maybe I could make a big A of x, which equals the opposite of little a of x. Or you could just put negatives in front of stuff. So here,
Could you also put negative a of x up there? Just put a negative
Yeah.
in front of a of x.
up here,
Yeah.
you couldn't put it in front of the A. That'll mess it. I think that'll mess it up.
Doesn't that make it upside
Yeah,
down?
I don't think that'll work well, but I don't know. I'm afraid to try because it might blow up on me. I'm just kidding. So there I get 152 thirds, which is 50 2/3. So now we're almost done. We just got to put those two integrals together. So we've got area 1, which was that 1 and 1.56 maybe? What was that one? No, it was 4 and 5/6. That's not good. Plus area 2, which is 50 2/3. 2/3 is 4/6. So let's see, that gives me 54. 4 and 5 is 9/6. 6 goes into 9 once. That's going to give me 55. And let's see what's left over, 3/6 or 1/2. Should be the final area. Put them both together. But you got to break it up. You can't integrate straight across, because if you try that, back to the picture, because they switch who's on top, depending on who you write on top, one of these areas is going to be positive and the other one's going to be negative. Okay, so that's got to cause a problem. So you got to look at the graph and see if they switch. And these extra boundaries just stop at those two numbers right there. All right.
Did we do one with 3 lights?
We did yesterday. Let's find one here.
There's a great one for number 8.
Number 8. Square root. Yeah, so sometimes the third function is just a line. So that was just a horizontal line. But yeah, let's give that one a try. All right, let me copy that to my notebook.
So is it kind of the same thing though? We have 3, because that last one was kind of like.
That last one gave us 2 more, not functions, but lines to bound things in. Yeah, so you got to draw it to figure out what region you want. And graphing utilities make this way easier than doing it by hand. All right, so whip out your graphing thing.
So wait, when it says sketch on the assignment, do we have to sketch it?
Yes.
Can we sketch it with a graphing utility?
Sure, but if I put this on a test or a quiz, you need to put a sketch on paper, so it's worth trying. All right, so I'm going to clean up this one and solve for y maybe. So that would be y equals 2 goes into 4 twice the square root of x. And then let's see, this one I think I'll solve. So 2y equals negative 4x. Plus 8, so y is equal to negative 2x plus 4. And y equals 5. So I'm going to take our chance at drawing this by hand. I'm guessing it's almost all going to live in the first quadrant, maybe. So let's see, that's the easiest one to graph. Actually, y equals 5. 2, 3, 4, 5. So there's y equals 5. My line has a y-intercept of 4. And then it drops to, I guess I need to scale down here. 2, 3, 5 maybe. So let's see, from 0, 4, go down 2 over 1, down 2 over 1. Something like that. It's kind of straight, points bigger. All right, so there is that, and then the square root, maybe I'll do that in red. So let's see. Square root of 1 is 1, but I got to double it. So it's going to go through there. 1, 2, 3, 4. Square root of 4. This is interesting. So square root of 4 is 2 times 2 is 4. So that gives me right about there. What's the next nice one? 9. Let's see, that's 5, 6, 7, 8, 9. Square root of 9 is 3 times 2 is 6. So somewhere up here-ish. So here's that function. Did I do okay?
Yeah.
All right. So sketch the region enclosed by the given curves. Decide whether to integrate with respect to x or y. Okay, so I believe then that I need to extend this, I guess, over a little. Oops, wrong color. The region I want is this one right here, is the region contained by those 3 functions. So does this region out here, is that contained?
No.
That heads off to infinity, and this function doesn't even exist on that side. Is this region over here contained?
No.
Now it heads out to infinity, up here, out to infinity, out there, out to infinity. Right, so we're trying to find the region enclosed or contained. And that's the only part I can see that's contained. You guys with me? Okay. So a couple options here. If I wanted to integrate, so we've been integrating with respect to x a lot of the time, which would mean I have this little sliver like this. So y equals 5 is always on top, but then I have to switch based on that intersection point for the bottom function. So that's going to take 2 integrals. No big deal. We can do 2 integrals. If I decide instead to integrate with respect to y, then the red one is always on top, right? Because this is getting bigger for x, and the blue one's always on the bottom. So I could do that one in 1 integral. Okay. So let's do it both ways just for fun. I'm going to do the y version first.
Just because you imagine that being rotated.
I'm not rotating it at all. So let me undo some lines here. So if I draw a horizontal line, which is really just a really thin rectangle, the length of this rectangle is the distance from the point on the red curve to the whatever point I'm on at the blue curve, right? And then the width of it is just, we would call that dy. Okay, so in this case, the length, however, would be the red, and the catch is there. I have to rewrite it as a function of y. So let's see, which one's red? That's the square root. That's this guy.
Yeah.
No, you have to.
No, this is
make
y
it
as a
equal to
function of
x.
x. I need x as a function of y to go
Oh.
sideways. Yeah, so this is y equals stuff with x. I got to write it the other way. So I would divide by 2, so I'm going to get a y over 2. And then how do I get rid of a square root?
Square.
Square it. So that means I'm going to square that. So that means my length would go from y over 2 squared down to the blue line. So up here I solve for y as a default because I'm used to that. I want to solve the other way. So if I go the other way, I want to solve that for x instead. So I'll have a negative 2y plus 8 is 4x. dividing by 4, I get x is negative 1/2 y plus 2 y. Yeah, so then I go minus parentheses negative 1/2 y plus 2. So, the trade-off is I had to solve for x here, versus if I go the other way, I have to do 2 different integrals. So there's trade-offs either way. There's no way around that. So this right here is the distance I need to integrate through. And then I need to move that rectangle from whatever y value I start at up to whatever finishing y value. So then my area here would be the integral as y goes from, they meet at y equals 2, and they stop at y equals 5. And then this right here is my integrand. So I'm going to rewrite it as y squared over 4, distribute, plus 1/2 y minus 2 dy. So come up with an antiderivative, evaluate that, tell me what you get. The setup is the hardest part on these. And then we'll compare that to the other way. Ooh, doesn't like that.
In Desmos, could we write down the function as like a function of
You-
y?
No, Desmos doesn't like that. You have to write it as a function of x. You mean the antiderivative
So
function?
like if I were to do like a of y is equal to,
It won't like that. I'm pretty sure it won't. I'm not positive. GeoGebra does not like that.
I could write it down just as long as I replace the variables with.
You put in the right numbers. So, anyone got a number yet?
And the bounds, if you flip it, are the y values, right?
The y values. Y goes from 2 to 5. So evaluate at 5, and then subtract evaluating at 2.
I got 9.
You got 9. 9 is what I got too. So hopefully we're both right.
Okay, cool.
Often I don't get these right on the first try. You got 9 too? Okay, 3 of us have the same mathematical delusion. Hopefully we're right.
Yeah, I got it.
Okay, so
Imagine us all being wrong.
it happens. So if my setup is good, then I should be all right. So my antiderivative function, let's up a little bit. So I got an antiderivative of x cubed over 12 plus, y. I had to put x's here because GeoGebra and Desmos only do functions of x. So y cubed over 12 plus y squared over 4 minus 2y. And then I plugged in my 5 to that, subtract, plug in my 2, and the end result is 9. So the area should be 9 there. Now, one cool thing about the way I've got it graphed here, it's got a scale that's 1 by 1. So I got a bunch of squares here. I can kind of estimate it, right? So 1, 2, 3, 4. There's 5 whole squares and a bunch of fractional squares. So let's see, 1, 2, 3, 4. These two make about 5. These two make about 6, 7. Yeah. 9 seems like a reasonable answer when you try and piece together triangles out of these squares up here. So it looks reasonable. All right, let's try it the other way. So, I'm going to redraw quick. Hold on. There. So we've got our graphs here. So they do something like that there. This one is y equals twice the square root of x. This one here is y equals negative 2x plus 4. And this one up here is our y equals 5. And we've determined the area enclosed. Always outline that on your paper. Is this right here. And some scaling values here. That point right here happens at 1, 2. I didn't calculate that intersection over there, but I'm guessing it is negative 1/2, 5 maybe?
Yes.
No. All right. And then I did not calculate that intersection over there. So let's do that next. That is where 2 square root of x meets 5. So to find that intersection point, let's see, we divide by 2. So x is equal to the square root of 5/2. So we have to break this into 2 integrals because they change who's on the bottom from here to here. Right? So there's going to be one integral that goes from negative 1/2 to 1. What's the top function in this region right here to get the height of this line right here?
Y equals 5.
Y equals 5 is on top. And what is underneath that? The line. So then I go minus parentheses negative 2x plus 4. So that's going to give me this area over there, dx, and then I have to add on the integral from, we're picking up right here, and we got to go that way, from 1 to the square root, oops, I messed that up. This should be the square root of the whole 5/2, square root of 5 over 2. Both of them are inside the root. So when I look at that region over there, I got to say, okay, here's my sliver, my little rectangle. The top of the rectangle is still 5. The bottom is the square root function in this case. So then I'm going to go from 5 down to minus twice the square root of x dx. I think so far this is a little harder than the other one we just did, but I had to think sideways to do the other one, which takes some practice. But sometimes it's worth it. Okay. So the hard part in any one of these is the setup. Once you get the setup, the antiderivatives aren't that bad. You got to carefully plug in. Okay, so we just got to be careful about that. And if you, I'm not going to finish this one because I did the hard part. We would just clean it up, antiderivative, plug in the boundaries. What are we going to get for an answer if we did it right?
we're gonna get 9 if we did it right. And some problems is about the same amount of work to do it vertically or horizontally. Other problems, one way is clearly the easier way. How do you know which way is easier?
You don't know until you
You gotta do them both, yeah, there's no way to tell. So things that set me off, like Trevor mentioned, sometimes the intersection point was a weird number, not a nice number, right? That's a clue that, hey, maybe the other way is easier, right? And the other way, I just had to go from 2 to 5, which was nice. Here, not only do I, one second, William, not only do I have messy endpoints on one side, but I gotta switch functions and do a second interval. Okay, so those are both clues like, I think I wanna go back to the other way. William?
Wouldn't x equal 5/2 squared?
Oh, yeah.
Oh, shit, I wrote that wrong, yeah. Thank you, I messed up my endpoint. To solve for the square root, I should square both sides, not take the square root. So it's gonna be 25/4, so that's not bad. Yeah, so this right here should be 25/4. Or, yeah, we don't wanna use mixed numbers are bad. Decimals are okay. Yeah, so that should be 25/4. Thank you, William. Now we should get 9. All right, let's try another one. Then I'm going to show you some 3D math. Let's see, what else looks cute here? Window, ooh, that looks challenging. The graphic is horrible, probably because I blew it up too much. Let's open it in a new tab. That's what it should look like. All right.
Except that one on there has numbers. One doesn't.
Oh, somebody drew numbers over the top of the image. Okay, so I got to zoom out so it doesn't look so crappy. Well, I guess it might look crappy no matter what.
Looks crappy on my computer, Jeff.
Okay, this looks crappy. All right, that's all right. Let's give this a try. This one looks exciting. On the screenshot, oh wait, new window. This one looks exciting enough that we might not get to do 3D graphing today. All right, so there's my picture. And where's the description? Okay. A window has a shape of a parabola above and a circular arc below. Find the area of the window. Use the dotted line as your y-axis and the solid gray line as your x-axis. So this is meant to be my x-axis, I'm assuming. Find the distance from the x-axis to the top of the circle. X-axis to the top of the circle. Okay. Thank you. Get that.
Not just 5.4.
So this is the parabolas on top, the circles underneath.
Oh,
Yeah. So I think they asked about the circle, didn't they? What was? Sorry, maybe I misread that. Find the, yeah, to the top of the circle. The circle is the lower one there. Okay. So I'm going to just redraw that in red. So this right here is some circle. And I want the distance vertically right there. Call that D for a moment. So I think, do I need an equation for this circle?
Yeah, you do.
Do they need to know?
Find an equation for the circle.
Yeah. So let's.
But it would matter what point you pick to get the distance.
Maybe.
And it doesn't specify a point, does it? Or
Um.
does it just want the highest? And how do you have to find that first?
Mhm. Let's see. So I'm going to draw this line here. That's 10.1.
But it's saying to which part of the circle is it saying that's 10 minutes?
The rate. So this must be the center of the circle down here, is what I'm assuming. So from this point to any point on the circle is always 10.1
How does that work?
because it's a circle.
The radius.
Oh, okay, yeah, okay.
That's the,
yeah, yeah.
yeah, I'm assuming
Oh,
this,
I didn't know
sorry,
that was the
I'm
radius.
assuming this is the radius. Sorry about that. Yeah, I wasn't clear about that. So I'm assuming that's the radius there. And then, let's see, if the 13 is the distance all the way across. So I get this right triangle here. That's 10.1 by
Half a foot.
6.5. So that means I can figure out this chunk right here. Does that matter? Do I need that?
Yeah, because you could
Well, now
I
you
think
know that
we
half
do,
of
yeah.
it's
subtract 10.1.
So Pythagorean theorem says take 6.5 squared plus that missing y value squared is 10.1 squared. So yeah, this is going to get a little messy, it looks like. So y would be the square root of 10.1 squared minus 6.5 squared, whatever that happens to be. Let's get the calculator out. So SQRT of 10.1 squared minus 6.5 squared. And Desmos is telling me it's about 7.73-ish. So this picture doesn't look very strong to scale. 7.73-ish.
So
That
subtract,
distance right there.
so subtract 0.1.
Yeah, so yeah, the total distance is 10.1. So that remaining top distance right there is, wait, do I even need that top distance right there?
That's what they're asking
Yeah, I
for.
don't, well, no, they want an equation. They don't want the highest distance, right?
Well, they
Let's go
want the
back.
feet and the equation. You want both.
Find the distance to the top of the circle, right? So that depends on where we are. So right in the middle here, it's whatever 10.1 minus this is. But over here, it's shorter. Over there, it's a little shorter. Over there, it's a little shorter. I got to find an equation for the circle. To do that, I need to identify the coordinates of the center. But I just did that, right? Didn't I just find the distance from the origin to that center right there?
Didn't we already know
Yeah,
that?
that's this number right here. Yeah, so that's the center y value. The center x value is 0. Yeah, so the center of this circle is the point that, crazy square root, 0 comma that.
Wait, I don't get why it's that. Are you doing just to the line, or are you doing this?
So I just, let me highlight it, blue. So I made this right triangle here,
Okay.
which gave me that side length right there, which is the distance from the origin down to the center. So now I know the y value of the center. Since that's the y-axis, the x value is 0. So the equation of a circle is x minus the center h value, x value that's usually called h, plus parentheses y minus the center y value that's usually called k, equals whatever the radius is squared. So we have an approximation of this using that number. Let's see, we have x minus 0, so that's just x squared, plus parentheses y minus that 7.373-ish number, equals the radius squared, so 10.1 squared. And we want the height here in terms of x. So we have to solve this for y now. So to do that, I'm going to subtract the x squared over. So 10.1 squared minus x squared equals y minus 7.73 squared. Take the square root. And then add the 7.73 over, is outside the square root. And then technically it's plus or minus, but I only want the top half. So I'm just going to go with the plus like that. So that's the equation of the whole top half of the circle. Okay. But that right there would give me, for example, this y value right there if I knew its corresponding x value.
Well, Why does it give us 5.24?
Because then it wants to find.
Oh, because I got to take the parabola into consideration next.
Oh,
Yeah, so that's why I said we're not going to get to something else this period because this problem's going to take a little bit. So we're just warming up. So far we just have an equation for the top half of the circle.
But we also need to find, we still need to find the distance from the x-axis to the top of the circle. Because that's asked for by Homer.
Yeah, let's see, that should be this right here.
That equation is
Yeah, if I plug in y equals, if I plug in x equals 0, for example, here, then what I'll get is a 0 here, right?
Uh-huh.
So I'll have the square root of 10.1 squared, which is just 10.1. Minus that gives me that distance we were talking about earlier.
We wouldn't be plus that.
Oh, shit. Which way is up on the y-axis?
Up,
That way? So this way is what?
down,
So is this a positive or a negative y value?
negative.
Negative. Oops. Yeah, that should be a negative y value. So we have minus a negative here. So that should actually have been a plus. Yeah, good job, Sarah. And then this one right here would be a minus. I knew something didn't look quite right, but I couldn't place my mind on it. Yeah, that should be a minus. So that's going to give me the y value of any point on the circle. And a y value is just the distance up from the x-axis.
Okay.
Right, yeah, so this right here is what they're asking for. So if I wanted to plug in stuff here, the distance from the x-axis to the top of the circle is that function. So SQRT of 10.1 squared minus x squared.
I think it
Close
looks like a
parentheses.
legit actual number, not an equation.
Oh.
yeah, because it's just says find the distance, nothing.
Oh, to the very top of the circle. So they only want that 1 point. Okay. So what is 10.1 minus 7.73? Does anyone get that?
3 point, but no. 2 point.
2.37?
Seven
Okay, so I
thirty.
guess they just want that number. All right. What's an equation for the circle? Let's see. I'm hoping they just want equation. So do they want maybe y equals what we just found? SQRT of 1.1 squared minus x squared, close, and then subtract 7.73. All right, equation for the parabola. Do that one next. So I need, this is scribbled on too much. Let's bring it to a new page. All right, let's see, what do we know about this parabola? We know the vertex. What's the vertex here? 0, comma 5.24. Okay, because I'm assuming this is the y-axis, and that's the x-axis. All right. We know 2 other points on it. So this right here should be the point 6.5, comma 0. Okay. And another one would be negative 6.5. And it turns out that's enough information to find the equation of a parabola. So I'm going to use the vertex form of a parabola, which is a times x minus h squared plus k. That look familiar?
We get it memorized.
That's just an
No,
increment.
I'd give it to you if you want it.
Yeah, it's when you do like the shifts.
Yeah, so this is just a parabola that shifted and flipped. So then we'll use this information to kind of fill in the blanks. So what do we know so far? We know that y is equal to some number a. What's x is, h is 0 here, so I'm just going to get x squared plus k, which is 5.24. To figure out what a is, I use this point over here, just plug it in. So if I plug in 6.5, I should get out 0. So 0 equals a times 6.5 squared plus 5.24. Solving that, we'd subtract over the 5.24. And then we would divide by the 6.5 squared. So a equals whatever that is. Now, their picture is not drawn to scale, so if we throw this into a graphing calculator, it might look a little squashed or stretched in comparison. But now we know what A is. So we know now the parabola is the equation y equals whatever that number is. I'm just going to write it as it is for now. Times x squared plus 5.24.
Good ending for it.
So now we have it all set up. Once it's set up, integrating is not that bad. The parabola is the top function, the circle is the bottom function. Ooh, interesting.
What?
We do not know an antiderivative for the square root of something minus x squared. Huh. What's the question asked next? Find the area of the window. Huh. Yeah, we have not gone over that yet. That's in like section 2.4 or 2.5.
We should take out the question.
No, it's too much fun. We can do a numerical derivative or integral, right? GeoGebra can do that. We just say integral between, remember that function we used before. Another way we could do it is, remember that cute program we used the other day?
The integral calculus.
The integral calculator. Yeah. Yeah, so you can plug it into the integral calculator. Yeah, so give that a shot tonight, and then we'll check that one out again tomorrow.
The assignment would be over.
And then, what's that?
The assignments.
The assignment's due tonight.
Tonight? Oh, okay, I'll move it over till tomorrow. That doesn't mean you shouldn't do any math tonight. You should try to do it tonight.
You are a god, but not the one that shaggy dope.